There is a planet where it rains molten iron, another where shards of glass fly sideways, faster than a bullet, and the third being eaten alive by its own star. These aren't scenes from a sci-fi horror movie. They are real planets, and we call them hot Jupiters. They are gas giants, much like our own Jupiter, but they orbit their suns so closely that they are literally burning to death. And here's the kicker: according to what we thought we knew about how solar systems form, they shouldn't even exist. Hot Jupiters were the very first type of exoplanet we ever discovered. Back in the 90s, when astronomers pointed their telescopes to the stars, they expected to find solar systems that look like ours, small, rocky planets close to the star and massive gas giants lurking in the cold, distant outer regions. But what they found turned everything on its head. They discovered colossal gas giants whipping around their stars in orbits closer than Mercury's is to our Sun. Planets with years that last just 3 days. 2 days, even less. It made absolutely no sense. Gas giants are supposed to form far from their stars, in the freezing depths of space, where ice and gas can clump together. Close to a star, there just isn't enough material, and the intense heat would blow away any gas trying to form a planet. So, how did they get there? The answer is a dramatic process called planetary migration. Hot Jupiters weren't born in the fire, they were dragged into it. They formed way out in the cold, just like our Jupiter did, but then something went wrong. Interactions with the swirling disk of gas and dust surrounding their young star caused them to spiral inward. Slowly at first, then faster, they journeyed closer and closer to their star's inferno, until they were trapped in their current, fiery orbits. And now, they're locked in a death spiral. Their atmospheres are boiling away into space, their orbits are decaying. And one day, they will fall into their stars and be completely consumed. Let's take a trip to one of these hellscapes, shall we? On the side of a hot Jupiter that permanently faces its star, temperatures can soar past 2,500 degrees Celsius. That's hot enough to vaporize iron. The night side, forever facing the cold of space, is cooler, but not by much. Winds roar from the day side to the night side at speeds exceeding 2,000 kilometers per hour, faster than the speed of sound. These supersonic winds don't just carry heat, they carry clouds. Not clouds of water like on Earth. On a hot Jupiter, the clouds are made of vaporized metals and minerals, sodium, potassium, and on some planets, silicate. In other words, clouds of glass. Take HD 189,733b, one of the most studied hot Jupiters. From a distance, it's a beautiful, deep blue marble. But get closer, and you'll find an atmosphere laced with silicate particles. Because of the extreme winds, it literally rains glass, sideways, at thousands of kilometers per hour. A beautiful, but utterly lethal world. Then there's WASP-1b, a planet that's even more extreme. It orbits so close to its star that the star's immense gravity is physically tearing it apart, stretching the planet into the shape of an egg. Material from the planet's atmosphere is being siphoned off, streaming away to form a glowing disk around the star. WASP-12b isn't just losing its air, it's losing itself. In about 10 million years, a blink of an eye in cosmic time, it will be completely devoured by its star, leaving nothing behind but a faint ring of cosmic dust. You might be wondering, could life possibly exist in such a place? On the planet itself? Absolutely not. The temperature is too high, the pressure is crushing, and there's no solid surface to stand on. Just layers of gas getting denser and hotter the deeper you go. until you reach a core of something truly bizarre, liquid metallic hydrogen. But what about its moons? Our own Jupiter has dozens of moons, and some, like Europa, might harbor life in hidden oceans. Could a moon orbiting a hot Jupiter be habitable? It's a long shot. The radiation from the nearby star would be incredibly intense, sterilizing any surface. But what if a moon was large enough to have a strong magnetic field and a thick atmosphere for protection? Then maybe, just maybe, life could find a way. Not on the surface, but deep underground, warmed by the planet's gravitational pull. It's unlikely, but the universe is full of surprises. The future for hot Jupiters is bleak. They are not stable. Every year, they creep a little closer to their stars. Eventually, their orbits will become unstable, and they will plunge to their fiery doom. We haven't seen this happen yet, but we've seen the warning signs. A planet called WASP-18b orbits its star in just 23 hours, and its orbit is decaying fast. In less than 1 million years, it will be gone, swallowed by the very star that gave it birth. These giant, migrating planets are also system killers. As they spiraled inward, they would have thrown their solar systems into chaos, ejecting smaller planets into the freezing darkness of interstellar space or sending them crashing into the star. Any rocky planets that might have existed in the habitable zone, any potential Earths, gone, destroyed by the arrival of the roaming giant. So how common are these destructive worlds? About 1% of stars like our Sun have a hot Jupiter. That might not sound like much, but with hundreds of billions of stars in our galaxy, that means there could be billions of hot Jupiters out there. Billions of solar systems torn apart, billions of worlds that never got a chance. And that brings us to a final, sobering thought. Our solar system doesn't have a hot Jupiter. Our Jupiter stayed put. It didn't migrate inward. If it had, Earth would not exist. We would have been flung into space or vaporized long before life ever had a chance to begin. When we look at hot Jupiters, we're seeing an alternate reality. A timeline where our solar system was destroyed. A universe where we never existed. They are more than just extreme planets. They are a warning. A reminder that planetary systems are fragile, that orbits are not permanent, and that we are incredibly, impossibly lucky to be here. Lucky to live in a solar system that stayed stable long enough for us to evolve, to look up at the stars, and to wonder. Thanks for watching. Don't forget to like and subscribe for more journeys into the cosmos.